on the surface, ekko is just a concentrate wash technology, right? So we have a number of these in the industry. A lot of them we have borrowed from other fields. And so our feeling was that they don't serve living cells in the same way that the ekko potentially could. And I'm saying that because the ekko is based on acoustic waves, so we do not have filters with fixed pore sizes and membranes. We do not rely on harsh centrifugal forces, but instead we have liquid handling, so there's a pump that moves liquid around through your normal tubing. But other than that, we rely on what we call a mesh of acoustics. And how that works is we have a transducer that emits an acoustic wave, and then we have a reflector that bounces it back. So it goes back and forth, and ultimately it just establishes a steady state bounce back and forth, which creates waves that are intersecting, creating a mesh, effectively, hence the ekko. The way this works then is you flow cells in suspension into this field, and they, due to physics, react to the acoustic forces. They get held back, whereas the liquid can flow through uninhibitedly. The cells then aggregate, not aggregate, but they get pushed to the nodes where the waves intersect. And as these pseudo aggregates become big enough, they will overcome G-force, or will succumb to G-force and drop down. So it is a snowflake effect, is what we say. But as a consequence, it is very gentle because there's very little shear force. And it's also very tunable. So different cell sizes, we can tune that a little bit. It's not a filter per se, so it is not as accurate as you say a 2-micron filter or something like that. We can filter somewhat to size, but we're also not impeded by size, right? So we can handle everything from a single cell to big aggregates or cells on a microcarrier. So from that perspective, it's very flexible. We can deal with large ranges of volumes and cell numbers. I think two of the real key differentiators for us are that we can handle aggregates. So we have a good number of customers in the iPSC space. These cells are grown in aggregates. And so we can remove single cells that haven't aggregated and are considered not good. And we can go down to very, very low volumes, down to 5 mils, which has been shown, and we've got really good data for pre-electroporation prep, right? When you try to concentrate your cells down as much as you can before you gene edit them through electroporation. Other than that, it does your typical concentration, wash, media exchanges, formulation at the end. So we always call it a multimodal workhorse.